Hey guys, this is a video of what we did on Friday in class. A lot of you guys were on a field trip, and we decided that this was a little complicated just to copy my notes that I scanned. So I decided to make a video for you guys so you don't fall behind. So basically this lesson was about trig limits. And here are two kind of famous trig limits. We actually did these in the calculator and showed them, but I don't have one with me in this room, so you're just going to have to take my word for it. But it turns out if you're trying to find the limit as theta approaches 0 of this function, it ends up approaching 1. And if you try to find the limit as theta approaches 0 of this function, it ends up approaching 0. And you can check that in your graphing calculator if you want. And just a note, see if you try to plug in 0, you end up getting 0 over 0. And remember, we can't do that, so we need like a trick. This is the trick. And same thing here, if you try to plug in 0, 1 minus 1 is 0 over 0. Again, we can't do that, so we need a trick, and this ends up being 0. Okay, so these are two new things for our bag of tricks for trig limits. For this one, the reciprocal is also true. The limit as theta approaches 0 of, I'm just going to take the reciprocal, theta over sine theta, and that's still equal to 1. But this one, the reciprocal doesn't work. Okay, so let's try some. So number one, if you try to plug in 0, you get 0 over 0, which again, we can't do, so we need to somehow make this look like this, meaning that this and this one have to be equal. And if you look at this guy, 3x and 2x are not equal. So we have to do a little bit of algebraic manipulation. So here's what I'm going to do. I'm going to pull out the 1/2. All right, and this first one's going to seem a little weird. Just bear with me. If I take out that 1/2, I'm left with sine 3x over x. And then I want you guys to think about, well, if we need these to be equal in order to use this trick, what could we multiply this x by to make it equal to this one? And I hope you're saying 3. So we're going to multiply by 3 over 3, because multiplying by 3 over 3 is just like multiplying by 1. So no big deal. Okay, now I'm going to group these guys together, and let's see what we have here. So now, what's the limit as x approaches 0 of sine 3x over 3x? Now that 3x and 3x are the same, we can use this rule. Sine of an angle divided by that same number is always equal to 1. Okay, so this guy really is just 1. So in the end, it's 1/2 times 1 times 3. All right, so it turns out that this limit is equal to 3/2. Don't worry, the more we do, you'll be fine. Okay, number 2. So same thing, we want to try to rewrite this so it fits one of these tricks so we can apply it. So what I'm going to do with this one is break it up like this. I'm going to put the things with the 3's together. So I'm going to write it as 3 over sine 3x, and then times, and then I'm just going to keep this one as like sine 4x over 1. So all I did was like break up the fraction. All right, so what could we multiply by? Let's see, we have a 3x and we have a 3. What could we multiply this one by to make these the same? And I hope you guys are saying x. So this guy we need to multiply by x over x. And then this guy, if we have a 4x, what do we want to multiply by here to make them the same? Well, hopefully you're saying 4x over 4x. And again, we always need to write it as a fraction, so it's like multiplying by 1. So we're not really like changing anything. All right, let's group some stuff here. All right, here we go. Let's group these guys, and let's group these guys. So what's the limit as x approaches 0 of 3x over sine 3x? We just talked about if these are equal, that's equal to 1. All right, so this guy is just 1. And then same thing here. The limit as x approaches 0 of sine 4x over 4x, that just goes to 1. And then what else do we have? Remaining, we have what's 4x over x? And 4x divided by x is just 4. So final answer, 1 times 4 times 1. This limit is equal to 4. All right, so we're just rearranging so that we can use our tricks. Okay, number 3. Again, you always try to plug in 0. But if you plug in 0, you get 0 over 0, which means we have to try something different. All right, so for this one, I would factor out an x from the denominator, and it would be 2x minus 1. And then I'm going to rewrite this as I'm going to group the sine x over x, and then the other fraction will be 1 over 2x minus 1. I just split it up into two fractions. Because now, what is the limit of this as x approaches 0? That's our trick. It's equal to 1. Okay, so this is 1. Now this guy, we can actually just plug in 0 for x. So what's 1 over 2 times 0 minus 1? Well, that ends up being negative 1. Therefore, the limit is negative 1. All right, moving on. Number 4. Let me get some new colors here. All right, for this guy, do you guys remember what tan 2x is? Just sine 2x over cosine 2x, right? Tan is just sine over cosine. And then dividing by x is like multiplying by 1 over x. All right, so just like before, I'm going to kind of group some stuff that goes together. So I'm going to group the sine with the x. So that's going to be sine 2x over x. And then the second one I'm just going to call 1 over cosine 2x. Okay, now we have a problem because these are not equal. And in order to make them equal, we need to multiply by 2. So I'm going to multiply this fraction by 2 over 2. This one, actually, we can just plug in 0 because cosine of 0 is 1. So this one, we don't have a problem. All right, let's see if you guys can see our trick in action here. If we group these together, what's sine 2x over 2x? Well, we know that that's 1. Right, so that goes to 1. And then times, this guy we can just plug in 0 because cosine of 2 times 0 is 1, and 1 over 1 is 1. And then don't forget we have this 2 also. So this one equals 2. All right, last one. So this one, let me get a new pretty color here. Okay, number 5. Let's do the same thing where we group them. I'm going to group x squared plus 5x together. Okay, so that'll be over 4x. And then the second fraction is going to be 1 minus cosine x over 4x. So pretty much what I did is just I undid the common denominator and wrote them as two separate fractions. Okay, so now if we want to find the limits of these, well, this guy, we can just factor out an x, right? And it would be x plus 5 over 4x. And then you guys know the x's cancel. And then if you evaluate this as x approaches 0, you end up getting 5/4. Okay, so this guy's just 5/4. And now we'll work on this one. So this one almost looks like maybe we could use this property if these were the same. Okay, but they're not. So the question is, what could we multiply 4x by to make it equal to 1? And hopefully you guys are saying 1/4. We need to multiply top and bottom by 1/4 because that's going to make this an x, which will match the angle x. All right, so let me rewrite this now. Now we have 1 minus cosine x over x, and then we still have times 1/4 here. So what I did is I grouped these together here, and then we had the times 1/4. And then, you guys know the drill, the limit as x approaches 0 of 1 minus cos x over x, this goes to 0. And then 0 times 1/4 is 0. So this limit ends up being 5/4. All right, so hopefully that made sense without being in class. Here's the homework on the worksheet that I scanned on Classroom. And then I believe I also posted all the answers as well. So yeah, thanks for watching, and I'll see you guys on Monday.